All right, quick minute video about cold working. So we just talked a little bit about directional rolling, right? X, Y, Z. So here's the handout that's going to be on here as well. But cold working, basically, the best thing I can do to explain it is I'm actually going to shoot to page 3 real quick. And so here's your original grain structure, right? So it's big coarse grains like this. And after it's cold worked, it's been worked down. As you can tell, those grains have become flattened and elongated, so they become a lot more dense, which also makes it harder. So here's now a good percentage, and now that you kind of get the visual to see what's going on here, now let's take a look at it. So a percent of cold working, look at the difference between 10 and 20%. We jump 5,000 pounds in tensile strength. Elongation drops quite a bit, so it's not nearly as ductile, and then it's a lot harder as far as hardness. And that might matter if we're looking at something, like say tool steel that we want to be able to cut into another piece of material with, right? We're going to cold work this thing. And so we can get a property that, say, is steel. This is all the same steel, plastic deformation on the properties of 730 brass, right? 7030 brass. That's pretty incredible. So same material, but look how much of it's been cold worked, and all of a sudden you go from that tensile strength to this tensile strength. So it's just been worked down and 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 worked down. So it's been layered, just like laminated wood, right? Wood structure, we think about 2x4s just laying together, big structures. But if you compress them and you do smaller, thinner pieces, then it's actually known to have really great strength as well. But again, it will be harder and a lot more dense as well. So our ductility is actually reduced as well by doing this, okay?